So I said that this is the galaxy's rotation curve. You may have noticed that there is no data in there. There's just a curve. So how do we know that? Actually, of course, it was determined by measurements. So these are several measurements that were taken to define the galaxy rotation curve. Let's understand how to extract that from observations. Basically, what we want to know is the differential rotation of our galaxy. That was an analysis done by Oort. Let's see how Oort did that. Famously, he defined the two constants called Oort's constants, A and B. So let's call this the Oort diagram. It's essentially an exercise in trigonometry. And this diagram is central then to understand galactic rotation. The sun's location will define the origin of the local standard of rest is at a distance r0 equal to 8 kiloparsecs then from the galactic center. The local standard of rest is moving at the velocity theta naught or v naught here in this graph, which is 220 kilometers per second. If we observe a star in the disk of the galaxy at a galactic longitude L, which is this angle here from the sun to the star, the galactic longitude then is just the angle between the star and the galactic center, right? This is the origin of galactic longitude. This is how we observe the star. So this angle is the galactic longitude. Now, assuming that this star is at z equals 0, that is, it's also in the midplane of the disk, the star is at a distance d from us. That's this distance here. Well, let's simplify it in this. So the sun, approximated that is equal to the local standard of rest, is going with velocity theta naught. The distance is d, and this is the angle L here, the galactic longitude. Now the quantities L and d, the galactic longitude and the distance d, are the things that we can measure. The star is at the distance r from the galactic center and is moving on a circular orbit then with speed theta. Question is, how can we determine the orbital speed theta r from observations of a star? So let's look at that in detail.